if there is a variable with number type and it is known as a, then I assign a is equal to 1. Okay, then I can apply arithmetic operations like, or we have learned about data types, so I will say instead of number a, I just write here integer a, that is int a. Okay, so a is equal to 1. Okay, so when I write like this, I can perform operations on top of it. Like I can add a plus b. So consider I have, if I have 1, and then this type, that is character a, is not, we cannot apply operations like this on top of this data. Reason? Because this type of data is called as character data. You cannot perform any operations on type of character data. Got my point? Alright. So we revised into the storage of data types. How the data types are stored. Okay. So last time, if you remember, we listed some data types with some prefixes like long, short, and double. Okay. Okay. So last time we listed these three prefixes: long, short, and double. What I told you is, consider normal range of integer is 0 to 6553. Then long integer will have the double range, so that you can store large amount of data. Okay. So how is that affecting? Alright. So I'll draw a structure of RAM first, how the RAM looks like, and then we can dive in. Alright. So consider Alright, so this is normal structure of the RAM. It looks like a matrix. Let me just alright, so this is what a typical RAM looks like. Okay, you have a memory with 9 different fields. First one is address, then these are bit. Okay, these are called as bits. Okay, each of this is bit, and you can say 8 bits is equal to a byte. Okay, so that is the basic formula of bit to byte conversion. 8 bits is equal to 1 byte. Okay, in that way you can have kilobyte, megabyte. So one, also write down the formula also. This is not important for you, this bit to byte conversion. Neither the entire RAM structure is important, but I am explaining you just to have a clarity of how computer looks like or how it works. Alright, so 1024 bytes is equal to 1 kilobyte. Okay, in same way, 1024 kilobytes is equal to 1, and variables in C++ in the upcoming classes. So I'll keep it like that and just have a look at this diagram and how it looks like. So we have some address like 1001, 2, 3, 4 and so on. Alright? So okay. So I am drawing a chart up here that shows how much byte space is required to store one variable of a particular type. One variable of a particular type. Alright? So I'll just have a look at this. Okay. First we have character that will have range that will be stored in 1 byte. Unsigned character that also requires 1 byte of storage, but there is a difference. It will be saved from -128, I guess 127 to 128. So it will be stored from -128 to 1. This is the range of the character, right? Then this will be stored from 0 to 255. Okay, so I will just make this a table. Just give me a minute. Dtype, here we have bytes. Here finally we have range. Alright. So one character requires one byte. So entire this address will be required to store just one character. And remember what I said about long, double, float. That float requires additional memory to store. Alright. Why is that? Because we have float. Float requires 4 bytes of storage. So if you look, integer requires only 2 bytes of storage. On the other hand, float requires complete 4 bytes of storage. That is the reason wherever we know that a thing can be run, okay, we can use int. Wherever we can use it, we have to, okay, so as to save the computer memory. Float requires -3.4 into 10 raised to 7 minus 38 till double requires 8 bytes. It also goes from 1.7, not minus, plus. Then raised to -308 to same 1.7 into 10. Long double is way more. Requires the storage of 10 bytes. It's 10, right? So this is the range of the integers and these are the bytes required to store it. Okay. Now I am going to teach you a shortcut by which you can remember these numbers. Alright. So one of the first shortcut is to find unsigned int and okay. Anyways, you have to remember this. Just keep in mind unsigned and signed letters have similar byte storage. So if you look at unsigned int and signed int, they have 2 look at unsigned and signed card, they have one character. If you look at float and double, they increase. Okay, so wherever you have unsigned and signed, there the byte storage remains the same. Got my point? Byte storage remains the same. Now, what can you do to remember these numbers? Okay, you have to remember this, but how can you remember these numbers? These are pretty huge, right? Then what you need to do is alright. So I'll first tell you to go for unsigned and then go for signed. Okay. So normally what you have in here is 1. Okay. So if you want to calculate this number, what you can do is 2 into 2 raised to 1 minus, sorry, this 2 into the number of bytes, let's call it 8 into b, okay, minus 1. Okay, so this is the formula for calculating unsigned character. This is the way you can calculate that. So let's calculate it for unsigned int. Okay, so unsigned car, sorry. Okay, what does it range as? 2 raised to 8 into b. What's b here? 1. So 8 into 1 is 8 minus 1. Okay, so this stands for 2 raised to 8 is 256 minus 1, that is 255. So you got 255, right? Alright. In similar way, if you want to go for character, then what you can do is do the second number. Got my point? Okay. So if you want to calculate for signed characters, the range will be 2 raised to 8 into b minus 1. Okay, that will give you this number, the left side's number, negative 1. And for positive, what you need to do? 8 into b minus 1. Got my point? This is how you will calculate the range for this. You can verify that it goes to. Okay. So we understood how the variables are stored and what type of byte storage is required to store them, and how they are stored inside the RAM. Also we saw the range type, the bytes, and how to calculate the ranges. Okay. Now moving on to the next part. But what I am going to do is input then a comma b. I am going to take the input from the user, and the user first number that user will input will be stored in A. The second number that user will input will be stored in B. Am I clear? Alright. So the first input that user gives is stored in A. The second input that the user gives is stored in B. Okay. So I don't know what exactly the numbers the user is going to give, right? I'm not sure what numbers the user is going to give. So what I do is store them inside a variable A and B. And now I want to add them. So I create another variable integer C. Then I say C is equal to A plus B. Got my point? C is equal to A plus B. And then I can show user C. That is, user will give me A and B what I am doing is showing him, see, that is I am showing him the addition of the two numbers. But my point, this is a basic C program, C++ program. It is not actually a C++ program. I am just showing you a basic idea behind the program that we are going to build, and that program will be our first C++ program today. Okay, so before that, let's jump on to constants. Okay, so consider once the user assigns me, before him assigning me a value of A and B, I keep A and B as 0. Okay, I keep A and B as I keep A and B as 0. What does that mean? Is if the user does not give any value, the default value will be 0. Or if something fails, the default value still will be 0. Got my point? Alright. So this is a concept of variable. What all you can do with the variable is, okay, we'll write it down. Okay, assign the variable. Okay, so you can create a user object. You can take input from user and assign it to the variable. Okay, you can perform operations. You can perform operations on top of the variables. Second part. Third part is very important. You can keep changing the value of the variable. Okay. So first A was 0. Now user, for example, that is me, I entered in an input as 1, 2. Okay. So now A here will be equal to 1 and B will be equal to 2. Alright, and integer C is right now nothing. Now 1, 2, this 1 plus 2 becomes 3, and I will, the display, that is output, will be shown to me as 3. Okay, but first the value of A and B was 0. I reassigned them. I changed the value of A and B to 1 and 2. Okay, so that changing of the values can be done in variable. Okay, and constants avoid you to do that. That's all. Okay, so consider you are writing a huge program. Okay, that happens in industry as well. So consider if you are writing a huge program and everywhere you have to show some circles. Or for example, if you are creating a shooting based program, will there be only one developer, one programmer? No, there will be many of them. Okay, in my company only there are 500 to 600 programmers in my division. Alright, so there are many programmers in the batch. Okay, everyone may be working on same project as you, or same, consider if you are a game development company, then they will be working on same developer on same game as you, or they can be working on some different game. Okay, now the problem that arises is very important is here. Okay, so you want to show bullet holes. When you shoot bullet, you want either to show the back of the bullet, that is bullet practically, and then you want to show the bullet hole. Okay, when it hits some metal object, or when it hits some doors or walls, whatever. Okay, so you want to show bullet holes. Alright? So you being a developer, you thought that why should I, whenever you have to show a circular object, why should you keep on writing pi as 3.14, 3.14? What you did is you declared a variable of it. Okay, that will be a floating type variable. I'll just write it down here. Okay, that will be a floating type variable. Float pi, is equal to 3.14. Okay, and wherever you wanted to use the circle, or you wanted to draw an area of the circle, you use this pi variable. Seems okay, seems cool, everything's working fine. Now problem happened. You left the company or you were on the leave, okay, and some other developer, okay, some other coder who was working on similar code, okay, who was working on same game, okay. So consider you are working on level 1 and that guy was working on second level of the game. Alright, he also created a variable pi but with different value. That value was 3.142. Now your circles and his circles do not match. But does this happen in real life? It doesn't, right? Why? Because you use something called as constant. What constants are? I'll show you. Instead of creating float, you write here what property of variable. End of the day you are going to combine all the code, right? End of the day you are going to combine the entire code. Okay, so by combining, your and his circles will differ in that way. Okay, and it is possible because variables have a property that you can change the input inside them. You can change the input inside them, and that is the reason this and this will work, but the game won't look nice. Why? Because same variables have assigned differently, and both of them are right. Okay, so, and even if you leave the company once, then two people will have to search for this file. Consider you have declared the variable pi on line number 100 and the code is of 1000 lines. The user or the developer who joined for developing the code after you did will have to go through the entire thing to search where exactly this problem is occurring. Got my point? So in that way, what we do instead of this is we write here const. What does this do? Okay, this avoids changing. Okay, you can assign, means you can first assign them, you can first assign the value, but you cannot change the value after it is assigned. Got my point? You cannot change this value after it has been assigned. You can perform operations on top of this. You cannot change it. That is what the operator, that is what the constants are. You got my point? Moving to the next type, that is string constants. I will keep this program as it is. We will move to the next part, that is called as string constants. What do you mean by string constants? Okay, they are also called as backslash characters. I write down the alternative names for the same. They are called as backslash then also you can call them as escape characters. Okay, And these escape characters are classic example saying that most of the languages are developed on top of C++ because these characters stay the same. Okay, these escape characters can be seen in C. Obviously, the first language that was developed is C. Then you develop C++ taking base as C. You took the base as C and developed C++, and then many languages got developed on the top of C++, like C#, Python, many more. I mean, Scala is one of those languages. C-A-L-A. Scala is one of those languages. So you can see that multiple things from C++ are adopted in these languages, such as the escape characters were first developed in C. Now they are used in C++, and also they are used in all other languages that are developed on the top. Alright. So what are these escape characters is something we will be learning. Okay. So right now I will be showing you how do you take, how do you show. Okay. Here I have, for simplicity purposes, I have just said that show C. That means it will show the output of C to the user. But instead of that, if you want to show something to the user on C++, you cannot use show. This is not the actual programming thing. No, neither is input, neither show. Okay. So for showing things to the user, you use a constructor or a function called as cout. Okay, it is called as cout, and after these two characters you can write hello. You can write something called as hello after cout, and it will show you the user, show the output as hello to the user. Okay, now this all is great, it looks cool, nice. Alright, now I have one question. I can write something like this. Hello, then space, then word. Okay, but giving this space here is good, no doubt. But what happens is sometimes if you want to give tabs, okay, you cannot give. Okay, normally when you are in Word, okay, you are writing some paragraph in here. Okay, all of this are there. And here on this line you give a tab. Okay, so the line starts from here. Instead of starting from here, it started from here. That is what happens when you give a tab. Tab is normally equal to 4 spaces. Okay, normally it is not a compulsion to have that, but it is used in that way. So you can have tabs as 4 spaces, and then you have this character. Okay, but giving 4 spaces in here. Okay, so consider what I want to show is hello. Okay, hello, then a tab and then word. This is a tab space. Okay, so here will be 4 spaces. Okay, so what can you do to show that in here? You got a question, right? If you enter tab, it will go to another line because you are writing something, right? Okay, else what you can do is give 4 spaces in here, but that's what the problem is. Have you ever observed that when you use a Windows computer and if you write a document in Windows, Word document in Windows, and then give it to someone else, that Word document is copied either on your pen drive, uploaded to the drive or whatever. Okay, you upload that, consider you upload that to the drive and share the link with one of your friends. and the friend will call you and tell you that brother, the document that you sent me is not formatted properly, because his version of computer, his version either of Windows, either of Word, is different than the one you are using. Alright, so ideally, if you are writing a code, okay, that controls the hardware, okay, so there are multiple codes that are system generated codes, okay, for example, to start the computer or to stop the computer, okay. In that case, the 4 spaces that you have defined in here may be interpreted or may be understood differently by the computer that you are using to deploy the thing on. So consider you worked on a computer that is your computer, a code, and you start a computer automatically. So you made a code that will start your computer. If you have a mobile phone near it and you press the start button on the phone, it will start your computer. Okay, that's the way your code is made. Okay, so the 4 spaces that you gave here and this, if they are different, then the code may be interpreted or understood by the computer in a different sense. Okay, it can be understood by the computer in a different sense. And what happens when that thing happens? It may hang the computer, it may not start the computer, it will cause the damage to the computer. So, there are backslash characters. This backslash character, if you want to write a tab in here, you cannot just give a tab space in here. You cannot give 4 spaces, they may be interpreted this way. They may be interpreted in a different way. So what can you do? In that case, you can write an escape sequence like backslash T. Backslash T stands for giving the tab space. So when you write hello backslash T world, the output will be shown as hello, then there will be a space of tab, and then, got my point? So while writing you write this, but while showing it will show out the space or tab. Okay. Then there are multiple things. Majority of them revolve around this thing. Okay. So what does computer do? Is that when it understands that there is a backslash character, it searches for the meaning of that character. Okay, so in that way there are multiple backslash characters like backslash n. This will jump your code to new line. Okay, so if you write something like this, hello, and then world, okay, what output will be shown to you is hello, hello, and in the new line there will be world. Got my point? They will be one below the other. So that is the new line. Backslash T stands for horizontal tab. Okay. Then you have backslash B. Okay. So if you write something like this, HELO backslash B and L. What it will do is that it will print out hello. Okay, how does this work? I will show that to you. Okay, when you write H, okay, you are writing, okay, so you wrote H, you move forward, okay, then you wrote E, you move forward, you wrote L, you move forward, you wrote O, and now you are here. Now you tell it to write B, sorry, L again. It will move back, write L, and then move ahead over here. Got my point? So this is how this will work. So if you want to give at every string, okay, every string, that is this is called as a string. Every string ends with something called as null character. Every string will end with something called as null character. Why is this null character important? Okay, this is called as \0. Why is that null character so important? The null character is important because it tells the computer or the compiler that this string is ending here and there won't be anything after this. You got my point? This string is ending here and there won't be anything after this. That is what a null character is. Also there are many other things like \a that gives out an alert bell. \a that gives out an alert bell. So these are the escape characters or the string constants that we will be seeing, and mostly using also these in our programs. Moving on to the next part, that is operators. So in this lesson we will be performing something called as operators. What are basically operators? Okay, they are symbols that perform functions. What are operators? They are symbols that perform functions in simple sense. Okay. So moving on, there are multiple types of operators. We first see these arithmetic. Arithmetic operators. What arithmetic operations are? Plus, minus, division, and modules. Plus, minus, subtraction, okay, I forgot multiplication as well. That's the reason I was looking. So, what a plus b is, so if you write 5 plus 6, it will give you 11. If you write 6 minus 5, it will give you 1. If you write 6 divided by, consider 3, it will give you 2. Okay, but modulus operator, it gives out the remainder. What it gives out? It gives out the remainder. So if you write something like 3 divided by 2, modulus divided by 2, it will give out. What is the reason? Let me tell you. So 2 ones are 2, minus 2. Now you can't divide, okay, you have to basically do this, add this, and then you can divide, okay. So basically this is the remainder, and that is being shown in here. That modulus operators shows you. So if you go for something like 5 divide by modulus divide by 3, the output will be 3. 5 ones are 5 minus 3 ones are 3 minus 3 2. So the modulus operator will give you output as 2. Okay, so that is modulus operations. And if you write 3 and the star symbol stands for multiplication. So if you write 3 into 2, it will give out 6. So this is what arithmetic operations are. Okay, moving on to the next operators. They are relational operators. Okay, so what are these? Less than, greater than, less than, equal to, greater than, equal to, and I guess more. Okay, so basically they give out true or false value. Okay, so consider if you want to find out which is the greater number among the given two numbers. Okay, so user will give out two numbers 1 and 5. And you have to tell which is the greater number. So you will show the user output, that is C out, as 5. Okay, how does that work? This is how it works. Okay, so let me show you 5 less than, if you apply 3, it will give out false. What does this false mean? This false mean that whatever condition you have written is not right, it is not logical, it is false. Okay, and if you write 5 greater than 3, it will give out true. Okay, but in this case also, if you write something like this, 5 is less than 5, it will give out false. Reason for this is that 5 greater than 5, no, because you have to strictly check for 5 greater than 5. But if you write something like this, 5 less than equal to 5, it will give out true. It is less than or equal to. What it is showing, less than or equal to. If it's equal to, right, then it will show true. Same goes for greater than equal to. And now, if you have to check something like, if 5 is equal to 2, it will give out false. Okay, it will just check if both the numbers are same or not, if both the characters are same or not. Same way, if you write equal to, if you give out true or false only, but in this case it will just show, compare if the two numbers are equal or not. This works in opposite direction of this. So if you write something like 5 not equal to 2, it will give out true. What does this mean? It is flipping the condition. Wherever this goes false, this goes true. So if you write 5 is not equal to 5, it will give out false. Got my point? So this one is not equal to operator flips the condition. If you write 5 equal to 5, it will give true in here. But if you write 5 not equal to 5, it will give false. Got my point? It just, this is called as not equal to, this is called as equal to, this one is called as greater than, less than, greater than equal to, less than equal to, greater than, less than. Okay? So these are the conditions. These are the relational operators. Now I will be going for something called as logical operators. What again are logical operators? We'll have a look. guys have studied logical gates, right? And or and not. What does this mean? Okay, so logical AND operation stands for a general AND operation. Okay, so let me write a sentence. Then write a small sentence, and you can figure out the meaning of this from the same sentence. So this is a small sentence that I have written. Remind me for C++ lecture when it is Saturday and time is 10:30 a.m. Alright. So this is a small sentence that we have written. Now I have fed this sentence to consider Google Assistant. Okay. Will the assistant remind me on Sunday? No, it won't. Will it remind me on Friday? No. It will remind me on Saturday. But on Saturday at any time? Will it remind me at 10 o'clock? Will it remind me at 10:15? No. Will it remind me at 10 in the night? No. It will remind me on 10:30 a.m. only. So, what does this AND thing do? What does this AND thing do is it checks that both of these conditions have to be fulfilled. This should be true. This should be true. And this also should be true. Both of them. When both of them are true, then only AND will accept the operation. Okay. So when I say remind me for C++ lecture, when this condition and this condition, this means when both of the conditions are true, then only the reminder will be sent to me. Got my point? So this is what AND operation does. Here also the same thing is done. Okay, there will be a relational condition before and after. Okay, so consider it is 5 less than 6 and 6 less than 8. Then do some job. Okay, then this condition will be true only when both of these conditions are true. So if I write something like this, 6 is less than 5, right? So you can't go ahead in the code because this condition is failed. But what happens when in the sentence itself I write or? What does or mean? When it is Saturday or the time is 10:30 a.m. When the reminder will be sent to me? It will be sent to me on Monday. Will it be sent to me on Monday? Yes, it will be, because the time is 10:30 a.m. on Monday also. So I get notification or reminder at Monday at 10:30, then Tuesday at 10:30, Wednesday 10:30 again, Friday 10:30, Saturday, all the time. Why all the time? Because it is Saturday. Okay. So all the conditions will be true when it is Saturday. Okay. This or this, right? So this is true. So this is no matter, we can do anything out of this. Okay. So Saturday entire time I get, and Sunday also I get the notification at 10:30. So what does this mean? Or condition requires at least one. I am again repeating, or condition requires at least one of the conditions to be true. At least one condition should be true. Okay. So if you write something like this, the same thing, 5 less than 6 or 6 is less than 5, it will allow you. It will allow you. Logical not condition. This is called as logical not. Okay. This not condition reverses the things. This not condition reverses the things. What it does is, if you have not condition and you have something inside of this bracket, it will reverse. So if you apply not true, then it will give out false. If you apply not false, it will give out true. In this way, logical not will reverse the condition that you are working. Got my point? Alright, so these are the stuff about logical operators. I'll be moving to the next one, that is assignment operator. Whoa. Assignment operator. Okay. When I say A is equal to 10, it is assignment. Okay. Now I can say A is equal to B plus C. This is also assignment. So this one moves this equal to sign. What it does, it moves the value of the right hand side to the left hand side variable. It moves the value of right hand side variable into left hand side variable. Or if it's a number, it will move it directly. Character also move it directly. Okay. So that is what it does. It will move the right hand side part inside the left hand side memory. Okay. Now there are also multiple types of assignment operations. So if you want to write A is equal to A plus B. Okay. So consider you guys are playing some time bound game. Okay. There is a time bound game. Okay. You have to complete a quiz within a given second. You have to complete a task within a given second. Okay. That is called as time bound games. Okay. So when you have a time bound game, such type of operators are very helpful. So if you want every second, you want the time to be reduced. Okay. So it's the game should be completed in say 15 seconds. Okay. So in 1 second it will show 40. In 1 second it will show 30. In this way the game will proceed. Okay. So here what I am doing is time remaining is equal to time remaining is equal to time remaining minus 1. That's all what I am doing, right? What I have in a code is I am showing the time remaining after every 1 second. So you have to write A is equal to A plus B, or time remaining is equal to time remaining minus 1. In that way, in that particular thing, what you can do is, there is one assignment operator called as a minus, okay, for time remaining, let's calculate for time remaining. Minus equal to 1. Okay, this statement, let me highlight it. This statement is equivalent to this statement. What my point? Alright, so in this way you have a is equal to a plus equal to b, a minus equal to b. Okay, same way as we did for time remaining is equal to time remaining minus 1, or in this way a minus equal to 1. Same way a, this will be translated as a is equal to a plus b. Okay, this will be translated as a is equal to a minus b. Then other operators like a, b, multiply equal to b, this will be translated as a is equal to a into b. Then a will be translated as a is equal to a divided by b. Then a modulus equal to b is equal to, or will be translated as a equal to a modulus b. Okay, so this concludes the assignment operator part. Now we can go for unary. Okay, so if you have a look at all of this, you will note down, you may have observed that every one of this operator other than this, other than logical and, all of them require two variables or two numbers or anything, that is two. It requires two declarations. Okay, here also you require a, b, this, that is what I am talking about. It takes two numbers or two conditions in case of relational operator. It takes two conditions again in case of logical operations. Instead of not, it takes only one. Okay, so whichever operations take two operators on the side. Okay, these are operators, sorry, and these are operands. They are called as operands. Okay, so whichever of these operations take two operands are called as binary operators. They require two operands to be on the side. This also. Okay, assignment also requires two operations, so that is also binary. This one, it requires only one operand. It is called as unary operator. Okay, in same way we will be learning couple of more unary operators. So now let's go for some more unary operators. They are as follows. First one is plus and minus. Okay, so they are called as increment increment and decrement operator. So when you write plus plus, so if you write a plus plus, it means a is equal to a plus 1. This is what it means. If you write a minus minus, it will mean a is equal to a minus 1. So if value of a was first 5, after executing this, it will become 6. If the value of a was first 5, after executing this, it will become 4. This is what increment or decrement operators do, and they are also unary operator. Okay. The second one, and probably the second last type of operator is conditional operator. Okay, first we will cover up binary operations. They are also called as bitwise operators. They are called as bitwise operators. Okay, so they are simple. Basically, they are not and or. Okay, so and yeah, so XOR, I forgot that. Okay, so these are bitwise operators. They perform operations on the binary digits. So these are bitwise operations. They perform operations on the binary numbers. Okay, so if you have, consider 8. 8 is translated as 1. 8 is translated as 1000 in binary. So if you apply NOT operator on this 8, it will be translated as 0111, 000. Okay. In same way, and or left shift, right shift, and left shift, right shift. I'll tell you. What left shift does is it will shift the bits here and it will add the 0 here. It will shift. If you again apply left shift operator, it will be 1100. If you again apply left shift, it will be 100. Okay. Then if you apply right shift operator, what right shift does, it will shift over here. So if you apply 0 to 011 and you right shift it, it will be 0011. Again right shift 0001. What's my point? So this is what left shift, right shift does. And or XOR, all these you have studied, so I won't waste time in these things. Okay. Moving on to the last type of operators. They are as follows. One is, these are custom operations basically. So they are called as, first one is conditional. Conditional operator. What it does is you will have an expression here. Okay. This is the only ternary operation, alright? All these are unary and binary. This one is ternary. It takes three things. Okay. Then you will have a question mark. Then you have value 1, and it will be separated by colon 2. Okay. So you have expression, question mark, value 1, colon, value 2. What does this do? So let's say you have 5 less than 6. Question mark here. 5. What does this mean is that if 5 is less than 6, it will give out 5. The output will be thrown as 5. If the 5 is less than 6, this condition becomes true. Okay? When this condition becomes true, then it will return this number. If it gives false, then it will give out the second number. Okay? So the later ones are pretty simple basically. They are scope resolution operators. Then they are most commonly used are pointer grouper. There are many of these special operators. I am taking only few of them. Okay. So this one is scope resolution. This adds a new line, then new declares a new memory, and set W sets the width. Okay. We'll all be seeing this. I'll just explain you one by one in brief what does this mean. Okay. So what does scope resolution mean? Okay. So consider inside a code, these brackets matter a lot. These brackets are called as blocks. Okay. So consider you write int a in here as 10. Okay. Then you write again int a here as 12. Okay. So what ideally should happen? The value of a should be now changed from 10 to 12, and when you show the value, that is see out the value, it will be a, it should be equal to 12. But that won't happen. It will show out the value as 10 only, because the int a is equal to 12 that you have used has assigned the value, created a variable and assigned the value only for this block. Okay. So if you want to take the variable value that is outside and then modify it, you have to apply this 4 dot operator. Am I clear? Alright. Moving on, the next operator, that is end line. Okay. So as we saw, means if I have to write something like this, just give me a minute, I clean this up. Okay. So consider I want my output to be, or if I am writing something like hello, what the output will be? It will be hello, and in the next line I will have word. Alright. So hello backslash and word, it will give a next line. Okay. In same way, it will also do the same thing as this. Here instead of backslash n I am giving end line operation. Got my point? Also set width. Okay. So if I write, consider this is the starting line, and if I write here, see out. Okay. What it will show is it will show hello like this. Okay, but I want it somewhere over here. I want to increase the space. So what I will do is hello, see out. Then first I will write set width 5 and then what it will do is increase the space and write hello over here. Okay, so 1 2 3 4 5. In this way it will increase the space. Alright, so that concludes the operator part in C++. Now we'll be moving on to the first C++ program, and I will be explaining to you in depth about what exactly are the operators, what are tokens, what are variables in the upcoming classes. However, in this program I will explain you what are processor derivatives, okay, how will you write the first program, where the data types are used, what's the type of most, what's the use of most data types and all those things. Okay, so this is the first C++ program that you may have written or about to write. Alright, so we will go step by step, okay, and dismantle the entire program to make it understand better. So what are tokens, what are data types and how they are defined, all these things can be understood from here. Okay, so first thing, this is the processor derivative. Okay, what does this mean? You are getting some another file, that is iosstring.h, into your code. You are using that file into your code, that is called as processor derivative. Okay, then this include, this thing is a token, okay, and this thing is basically a keyword token. Okay, so what does this mean? This is reserved. What include will do? Include will go and fetch this file and load it into your program. Then what is void is again a keyword. And what does it specify? It specifies the data type. What is main? Okay, main function is basically the function which will start as soon as you run your code. Okay, so if you have many functions, okay, you can have many functions, but they can be called. Main function need not should be called. All these things we will learn in detail as the class proceeds. But right now you just have to keep in mind that this is a function and it's of void type. That means it has no data type as such. Okay. Then what does this mean? All the code inside the main clause should be inside the brackets, curly brackets. What does cout mean? Cout is a keyword. No, sorry, not a keyword actually. It's not a keyword. It's a token. And the function is Cout. Why do we need to include this file? Is because the code for Cout is written inside this function. This library or this file has the code for showing the data onto your screen. So iOS screen shows the data onto your screen, and this is what Cout does. Okay, this is again your string, and this is an escape character. Okay, it will basically print the two words on the consecutive lines. So guys, that's all for this lecture. Thanks a lot for hearing to me this long. Thank you.